Hello, hello. If you can hear me, just type in the chat. I'm speaking right now. All right, okay, sounds good. So I guess we'll just wait for more people to join. I'm not sure how many people will join, but we'll see. All right, cool. Yeah. Do I have? Can I actually? Okay, okay, cool. All right, sure, I can do slides. So this is just based off like Ahad's previous presentation, right? So let's go through this. So just kind of recap, right? And then I just talk about what's in today's workshop, basically, right? And then I switch it over to the notebook, has like everything. Yeah. So most of the presentation is going to be on the notebook on Google Colab. So let me actually share a link to that. Yes, this slide. Yeah, I can share the Colab link. Give me 1 second. It's pretty long though, so. Okay. Yeah, it doesn't seem like you have too many people joining. It says 2 people, but I think one of them's just me. I'm not too sure. Yeah, if there's another person in this chat, just like send a message. What's up, Andrew? How's it going? Okay, it's 7. I think I'll wait a few more minutes for other people to join before we begin. So You guys can chill. Yeah, I think on Monday, Ahad said that we were gonna have a follow-up workshop. I don't think we discussed like when, but I mean now is when we're doing this. So yeah, yeah, this was kind of like out of the blue. Yeah, next time we'll probably schedule it like in advance. Just have an announcement beforehand. So yeah, it seems like we have 4 people here. Yeah. We'll wait a few more minutes. Let me actually, how do I pin this? Wait, Suresh, can you access the collab link? Are you able to like use it and stuff? Just let me know. All right, sounds good. So I can actually pin that. Let me see. Um, is it? I'm doing this through StreamYard. I don't know if it's actually pinning on the YouTube thing, on the actual YouTube stream. Is the link pinned on there? All right, let me check here actually. So let me go to the actual YouTube page. All right, so it should be pinned now. Cool, cool, cool. Um, yeah, pretty low turnout rate today, but I'm just gonna get started. So for people who join, so yeah, so basically this is a follow-up workshop to the previous ML Monday, right? And last ML Monday we talked about computer vision, right? More of like the conceptual side of things, and also more of the introduction to that, as well as like how it works as well, right? This is more on the implementation side, right? So we're going to be showing some code. This will also use some of the concepts from that previous ML Monday as well. So you'll see that as well, right? Okay, so let's actually. Um, okay, 2 people left. All right. So let's actually just start this, right? So just to recap, over last lecture, we talked about different types of computer vision, right? So you have the classification, like basic classification, right? So you see what category of images or what category this image basically falls under, right? Then you can add a localization component, right? See where the object is within the image, and then you have the object detection, right? See, like you have multiple objects within a image, and you're able to detect them like that, right? Let's go to the next one. Next slide. So we talked about different other applications of that, like pose estimation, right? So you're able to track body parts as they move, and then you have the event detection, right? So you're able to see people as they move, and just basically just tracks each person's movement, right? Um, Yeah. So we also talked about how computers view images, right? So essentially, it sees it as just a bunch of numbers, right? That's kind of how a computer interprets things, right? So, you have a bunch of pixels, and you can actually um, like classify them based on like how intense they are, like how intense the colors are, right? So that's kind of how that works, right? Give me 1 second. Mm, Let me share a link here. Um, so yeah, so we covered how computers view images, and we talked about the concept of convolutions, right? So this is a pretty important process when we're talking about convolutional neural networks, right? Uh, so this is a pretty important announcement. I mean, this is a pretty important concept within that, right? And we'll actually be covering that within the code as well, right? So we'll actually have a notebook that actually has code that basically shows how the convolutions operations work, right? This is actually supposed to be a GIF. I'm not sure why it's not playing here, but essentially you have like a kernel, right? And that kernel would be like a matrix of 101, 010, 101, and you essentially multiply that by each region of our input, right? And you multiply multiply by the region, and then you sum all the values in order to get like a certain value, and that value will make up one of the values of our feature map, right? And this is pretty important when it comes to these neural networks, right? Okay. Then we also, and you can see all the processes within the convolution neural network, right? All the different layers, right? So you would essentially have that convolution operation, you know, just have that done multiple times, right? And then you have all these processes, right? And you basically end up with an output, right? And that's kind of how that works on like a larger, from a larger scale, right? We also talked about pooling, right? This is also a pretty important operation within these networks, right? So you have max pooling, right? And that's pretty self-explanatory. You basically get a region of the matrix or our image, right? And you basically get the max value within that region, right? So as you can see here, we have the first region has like 29, 15, 0, 100, and the max value within that is 100. So yeah, that's how that works. We also have average pooling as well. So that kind of just takes the average of that instead of just the max value, right? And we'll also show this within the code as well, right? Um, so the next one. So today's workshop, we're going to be covering the implementations of computer vision, right? So convolution operations, max pooling operations, the structure of a convolutional neural network, also how to train the network as well, right? And we're also going to be talking about how you use a pre-trained vision model as well, right? So yeah, before I get into the code, let me do this. Yeah, I think, yeah, the one guy left, I think. Yeah. I'm not sure if I should still continue with this because I think it's pretty much no one here. What do you think, Storage? Yeah, if anyone else is here and wants to learn, like, just type it in chat. I'll go over all of it. Oh, now there's three people. Okay. Yeah, if you're here, just type in the chat saying you want to learn or something, and then I'll actually go over it. So no one. Okay, so we got one person. So I'll actually go over it just to show Andrew, right? I think you can also see like I don't know if you can see the collab link like pinned as well, right? So you can actually follow along with that, right? Let me actually share that. Um, Give me 1 second. Delete this. I'm not sure if you can see that on your screen. Okay. Yeah, it seems kind of blurry. I don't know how to change that. Let me see. Mhm. Andrew, can you see like the whole thing or no? Like, can you see the? Seems kind of blurry on my end. Let me make an announcement in Discord. Alright, cool. Hold on, give me 1 second. Yeah, hold on. I'm trying to see if I can make an announcement on the Discord. Alright, so let me show you. Okay, so alright, so let me just go run through this code. Right, I think we'll kind of cut this session short since there's not too many people here. So yeah, so basically, first part we're going to cover is computational and pooling operations, right? So we already covered that earlier, right? So basically, you have a kernel, right? You basically multiply by each region of the image, right? And you multiply that and you add all the values, and basically that gives one of your values in your feature, right? So I did put a code snippet right here that kind of showcases that, right? So essentially, you have an input image. Uh, this is an array, right? And you have a kernel right here. So you have a kernel right here, and essentially does what we just talked about, right? So um, basically, first thing we have to do is define our feature map, right? So in order to get the height and width, we just subtract the height of the image with the height of the kernel and add one to that, right? So as you can see here, right, 5 minus 2, that's 3. right? So plus one, and then you'll get, that would mean that you'll get a feature map of 4 by 4, right? And then after that, we initialize our feature map. So it's going to be filled with all zeros, right? So it's essentially a 4 by 4 matrix with just a bunch of zeros, right? Next thing we do, we actually perform our convolution operation, right? So we essentially go from left to right of the image, right? So we go just get every single like region, and basically we multiply that by our kernel, right? And then we just get that feature map, right? So yeah, extract. So yeah, we just extract the region of interest. So for example, that could be like um, here, right? Just 312. Actually, it would be like 3125, right? And it would multiply by the kernel, and then you can just multiply that here, get the sum of that, and then we pick up one of the parts of our feature map, right? Okay, so you may actually run this. Um, yeah. So as you can see here, we get our feature map. So as you can see here, it is a 4 by 4 matrix, right? And it has all those values that we calculated. Does anyone have any questions so far? I know I kind of speed that, but chat. So just gonna move on. No one has any questions. So next thing we have to do is use a max pooling operation, right? So this essentially is the next part of our convolutional neural network, right? So this would essentially make up like the second process after the convolution, right? So we're gonna actually use that feature map we just had from here, and now we're actually gonna perform our pooling operation, right? So we have our feature map, we just basically use that same one from before, right? And we have our pooling window size, right? So basically just the size of the region we want to get the max value of. Is essentially what that is, right? Next thing we do, we calculate the dimensions of the feature map, right? Just get the output height and the output width, right? And that will basically get our like final values, right? Or our not our final values. That will basically be the sizes of the regions we want to get the max. What that is, right? Um, so yeah, that's our output, and we then initialize our output feature map with just a bunch of zeros. So that's kind of how it starts off with. That's how it kind of starts off with, right? Then we actually perform our max pooling operation, right? So we just use a nested for loop. We just go left to right. We get our region of interest, right? So our region of interest would be like this red area right here. It would get that region of interest, and it would then get the max value of that. So in this case, the max value would be 20, so it would be 20 here. And for this one, so since we're doing it by just 2 by 2 pooling, so this max value would be 15 right here. This max value would be 14, so on and so forth, right? We can actually run this. So here we get our feature map after the max pooling operation. Yeah, so the pooling basically it does essentially compress our image. Right? Um, I actually have a diagram. Yeah. So this kind of shows the whole process. Right? So we get our image, we multiply it by our kernel by by each region, right? We multiply each of the regions by our kernel, and then we get our feature map, right? And then we use that max pooling operation and essentially get a smaller output, right? And um, yeah, that's kind of how it works. So yeah, you're right. It basically means like compress the input value. Does that answer your question? So we're gonna run through this convolutional neural network, right? And basically, this is the full process of, or basically the full process of how a neural network works, right? So as you can see here, we have our same convolution operations, our same pooling operations, right? So we get our input image, we perform convolution operation, then we perform max pooling. Then we do that convolution operation again, right? Just the same thing, except maybe with a different kernel, right? And then we perform a max pooling operation. And after that, we have our fully connected layer, which and before we actually do our fully connected layer, we have to flatten our values, right, or our channels. So basically, we then get our neurons, and that will basically get our output, right? And as you can see here, this is classifying numbers, right? So you can see these different outputs, right? All right, cool. So I do have an example right here. Uh, so as you can see here, this is kind of a similar thing you just see right here. So you have these different layers of our network. So first we have the convolutional layer, right? So that's what we've been talking about, right? We have our input channels, right? So the three basically means RGB, right? So red, green, blue, just the different like intensities of that. And as you can see, we have our kernel size as well, right? So it'll be like 3 by 3. And then we have our output channels, and then we have our padding as well for our parameters, basically. And then after that, we perform a ReLU activation function, right? So basically all that does is it converts our negative values to 0. So this kind of introduces nonlinearity, kind of, and it allows us to make better models, right? More complex models. So that's kind of what that does. After that, we then do our max pooling operation. So we first define our dimensions. So this basically means we're having a 2 by 2 pooling operation. And the stride basically is how much that pooling jumps between like each value essentially, right? Hopefully that makes sense so far. And then after we do that, let me see if there are any questions. So after we do that, we do that again, right? It's in our second layer, right? So we do a convolution operation. We use our ReLU activation function again for a max pooling operation. And yeah, after we do that, we then use our fully connected layer, right? So yeah, but before that, we would have to compress our values into a tensor or a one-dimensional tensor, and then after that, we can actually connect it to or use a fully connected layer, right? And as you can see here, we're connecting it to 128 neurons, right? So as you can see here, it kind of details that. So we flatten it and use it as a fully connected, right? Is there any questions? Okay. So yeah, so basically right here we're simply just defining our layers or defining our architecture. This function actually has our input go through these functions, right? So first our input goes through the convolutional layer, then it goes through our ReLU activate function, then it performs our max pooling operation. It does the same thing here, right here, right? And this is actually where we're flattening our tensor. So this will allow us to make our have our fully connected layer, right? And then we perform our ReLU operation again, and we have another final fully connected layer at the end, right? And this will basically get our output, right? So does that make sense to whoever's watching? So I do have an example for training right here. I'm gonna go through this a little quick, but basically we define a data transformation pipeline. So basically, whenever we process our data set, um, whenever we process our data set, we first have to normalize it, right? We're normalizing our input data, um, and so yeah, that's kind of what that does basically. So then we define our batch size. So this basically is represents how much size each, like, I guess, batch of data is being processed per training iteration. Right. All right. Cool. Yeah. If you have any questions, Andrew, just let me know. Yeah. Um. So yeah. So we define our pipeline, get our batch size. We load our training data set. This will allow us to train our model basically. We create a data loader. So this will get our training data set and allow us to train it on our neural network that we just made right here. Right, let me actually run this. Yeah. And then after that we create an instance of our neural network, right? So, this is actually just a class, so we're essentially just creating an object based on that class. So then after that we define a loss function, right? So this will actually help us measure how well our model is, outputting values in comparison to the actual values, right? And the actual values are once again, within our data set, right? So this loss function is kind of what actually makes our model accurate, right? It actually is what improves our model. So that's pretty important. Yeah. So then after that, we define our optimizer. So this will basically adjust our parameters in order to minimize the loss based on what the loss function is. Based on our loss function. Then after that, we actually go through the training loop. So we're running this for just basically 10 times, right? And then we basically go through each batch of data and just train within our neural network, right? So, mm, so now my output's on. So let me actually run this. It might take a little bit, but yeah. So yeah, we're essentially this is essentially a training loop, and uh, yeah. So we basically calculate our loss value, form back propagation, and basically updating our model weights as we're training it, right? And so essentially, improve our model or improve our neural network. So does anyone have any questions so far? It seems like time kind of reset, so I have to run that again. So basically, what this is supposed to show is just like different loss values, right? How much, like how different is our output compared to the actual value, to the actual real values. So that's kind of what's supposed to be shown right here. It kind of takes a while for this to train, so I'll do that. I'll do that. So then we're actually going to use. So yeah, that kind of finishes that. So now we're actually going to see how to use a pre-trained model. So essentially, with the pre-trained model, you're just kind of fine tuning it, right? So basically, we just get a data set of dogs and cats. We use our data loader to get our image files. So right now we're only getting just 100, right? Um, and then then we use the vision learner. So we get that from the Fast AI library, and basically we're just fine tuning this model, right? This is okay. And then so this kind of just defines our data. Then what this is, basically I'm just getting an output for a output test, right? So I'm basically searching for an image of a cat to see if our model actually works, and then at the end we get our prediction results, right? Okay, so you can see our models running right here. So you can see our loss value is decreasing over time, right? So it starts off with 2.12, 1.71, 1.52, right? So you can see here that like our model is essentially getting better and better, right? It's basically improving after every iteration, and yeah, that's kind of what's happening right here. So this is actually the same model we just defined here, and as we keep training this, the loss should probably like I guess uh, end up being at around like 1.1, right? I think that's kind of what's going to be at like iteration 10, right? So you see it keeps yeah 1.4 now, right? So yeah, I'll let that run, and then actually I might try running the pre-trained model if you're interested, but yeah, but the main idea is just this part, right? Just the convolutional neural network. Hmm. So does anyone have any questions? Yeah, yeah honestly, I might end the stream if there's nothing else. Yeah, if you're here, just type in the chat. Everyone's here. Okay. Okay, it seems like no one else is here, so I'm actually gonna end the stream right now.